In parts 1 through part 3, we covered the concept of target words, surrounding words, context words, and stop words, and how they all relate to the process of tokenization. In part 4 through part 6, we dove deep into the continuous bag of words and skip-gram approaches and explored how training samples are generated for each using schematic diagrams. The end goal is the same in both continuous bag of word and skip-gram, that is to learn meaningful word embeddings. However, they take different approaches to achieve this. So why do we need two different approaches to accomplish the same goal? More importantly, given a particular data set, how do we decide whether to use continuous bag of words or skip-gram? What factors should drive that choice? In part 4, we saw that continuous bag of words uses the context word to predict the target word. In part 5, we saw that skip-gram uses the target word to predict each of the context words. The difference in the number of training samples is significant. As we saw in part 4 and 5, with a context window of 2, continuous bag of word generated 88 training samples, while skip-gram generated 132 samples for our dataset. In a typical dataset with millions of sentences and potentially larger context windows, the number of skip-gram training pairs can become much larger. This makes skip-gram more computationally expensive and generally slower to train than continuous bag of words. So, why would we choose skip-gram if it requires more training? One important reason is the quality of the learned representation. The original Word2Vec work found that skip-gram can capture more precise semantic and syntactic relationships and tend to perform better for infrequent or rare words, although the actual results depend on the dataset and training configuration. On the other hand, continuous bag of word can be a good choice when you have a large data set with predominantly frequent words and you want faster training. We now have a solid understanding of how Word2Vec prepares data for training. The next few topics, such as one-hot encoding, vector embeddings, neural networks, loss functions, softmax, and backpropagation, are not specific to Word2Vec. They are fundamental concepts that appear across many areas of machine learning. If you are already familiar with these topics, feel free to skip ahead. However, if you would like to see how these concepts fit together and are applied in the context of Word2Vec, you may find it useful to continue with us. Check out the other shorts to complete the full series. If you like this video, hit the like button and subscribe.